So probably modal analysis is not useful anymore to find those minor errors because they don't cause a major instability. So what we can do, we can come here and use other displacement. So I can come, for example, to wind xy. I just need to just explore. Really, there is no formula, there is no specific way to find them, but now you can see you need to check different wind conditions in x and y to ensure that nothing is missed. So now you can easily see that other elements are okay, but this element moving, that means there is an instability here. So we need to fix this one. The other way, if you really need, is trace and check the movement level by level. What you need to do, you need to select levels one by one by set view limit and deselect whatever you don't want to see for clarity. For example, so we've done this one for roof because we have a group of a steel frame, which is fine. If I want to do this for level below the steel level, which is this, what I need to do, I need to create my set view limit. So this is currently, if I put it on deform shape, I can see this is Z11. So the lower level here is Z8. So I can come here, set limit for view from Z8 to Z11, apply. I just can see this part. Do I want to see below? Probably not. Or I may not want to see above level. It's up to me. I can deselect them. How I can do that? I can select them all. Then I can come to this and rotate it and align it exactly in one line like this. If I want to select top, I will go for this. If I want to select bottom, I will go for this. So let's assume we want to deselect below. So I'm coming here, deselect by window, and then I use window, not crossing, for this level. And then I put show selection only. I must be very careful because I may choose this one. Is really back to the way you guys can see. You can see here that all of them are selected properly. So you can come here. The other one is just deselecting the section of those slab exactly. But now we can see everything here. Very good. So let's back to gravity, because here wind or lateral load doesn't give you any valuable information. You can choose any gravity load combination, it really doesn't matter. If the automatic doesn't give you a good scale, you can choose user define if you want. So I can come here and scale user define the way I like, say 50, and make it more accurate for myself. You can see the displacement here are a bit more exaggerated, which is perfectly fine because I'm just tracing what's going on. I will start and I can see things are moving smoothly. There is no instability at this level, and I can do the same for all levels. You can see here some elements are moving very small. If you are in doubt, you simply can come here and use this and come closer and see exactly what is happening here. So if I start animation now, I see no, there's nothing special here and all good. So it's fine. Now what I need to do, I will back to 3D. I'm just showing you a couple of levels because I really mind the time. There is a lot to do and to say, guys, but it cannot be condensed in just 10-12 hours video we have with this course. But I'm quite happy to help you in our workshops, and after that you can reach me out if you have any question. I'm I'm pretty happy to help you and sort out the issues you have. So let's do the same for lower levels. For example, I can come to set view limit and change this one from 4 to 8. Apply. Now I am in lower level. I can just try here and see if there is anything not clear for me, then I can remove the lower level. I'm going for start animation. So what I need to see is mainly the column I have here. So let's move a little bit closer to see what's happening to this column. You can see the automatic mesh here now done by SAP, but looks like the column is moving correctly. You can see the connection here between joints. There is no difference between the joints of the mesh of the slab and the column joints, so all connected together properly. It looks alright. Let's move to the lower level. I need to do this just to show you the walls below. It's fine, it takes a little bit time, but it's better to show you guys. I'm trying to show you what you really need to do for detecting errors. So I'm coming here again, I'll show, okay, it's perfectly fine. This is the one that I auto mesh. You can see the slab is auto mesh. Now I'm moving to the other one, and here is the auto mesh by SAP. Those are dummy joints. You can see the joints are green. The main joints I have are black. So here the joints are black, but this one the joints are green. But you see it's uncontrollable. It's SAP, actually it's up to SAP how to do that, and you cannot find exactly why it's like this. It's back to the arrangement of the joint. You can see you have one joint here, one joint here. So SAP actually do this for both of them. That's why it's happening. But the result is the same. It's just a matter of avoiding of complicity and make the analysis more complicated, so you can track the errors easier. So looks like everything is fine. I'm just doing this one for the basement, and then we can move on for the rest of the process. I'm coming here again, set limit. I'm coming -3 and 0. So this is the last part I have, and I can again choose COM-UG2 and apply. I'm going a little bit closer. Okay, now see what we have got here. Okay, it's moving well. Okay, what we have here, this is one of the mistakes I can see now. You remember initially we had a pad footing and then we changed it to pile foundation. Probably we forgot to remove the spring of the foundation. That gives you an additional stiffness, and that will affect the result of the analysis for the pile, because partially the load will be taken by those surface spring. So you need to remove them to ensure that the pile is taking the whole load and you can get the accurate result. You remember we didn't subdivide the shell or frame here. You can see the discontinuity here between the frame and the shell. If I go closer, that's the consequence when you have a big shell or beam without any connection. You can see here structurally it's okay because load will be transferred to the columns, but actually the load wouldn't be transferred to the beam. So the moment you have for the beam is not correct, because beam doesn't take any load, depends on the stiffness of the shell. Shell cannot be constrained at the edge with the beam. You can see here it's not happening. And also you can see here that wall and foundation, or wall and slabs, are connected properly. Let's move on to upper levels again and see what happens when we have those joints here. So I'm coming here and I go to view again, set limit, and I just move one level up, so 0 to 4, apply, and then I apply displacement. I'm zooming in here, and if I start animation, you see all of them are properly connected together because of the joints. Doesn't matter if you divide shell and automesh the frame, or divide frame and automesh the shell, the result would be similar. Okay, so let's unlock this model and just update some minor errors remaining. So I'm coming here in view, set limit, show all. Now I'm rotating this frame and just go to this area that I know I have an error. I need to connect these two together. I'm choosing this point and connecting this point to here. So sometimes there are some mistakes. You can just delete this joint. If you see it's still there, it's not correct, because you actually stretch this element and extend it to this joint, so you shouldn't see another extra joint here. Another thing I would recommend to do is you need to come here and press Ctrl A and come to assign, go to area, edge constraint. You have walls and slabs, and sometimes you have two slabs next together, but they have different arrangement of auto meshing or subdividing. What you need to do, you need to constrain the edge so they are connected properly together regardless of the arrangement of the joint of each shell. So I will create constraint around area object, apply. Now we probably shouldn't have any error. The only thing remaining is removing area springs of foundations. So we're coming here, select all of them, coming to assign, area, and area spring, and press delete here, apply, and close. And for analysis, we need to also activate all analysis cases. So few of them was do not run because we were in trial and error procedure. Now we want to change them. I can come here and select them and again put run, do not run, or simply I can come here, run, do not run all. But I need to check what will appear in action column. You can see all of them are do not run, so I need to press one more to change them to run. And the rest are fine. One more thing I would like to share before doing analysis. In set analysis option, we have solver options. So we can go for a standard solver, leave it to SAP, or come to advanced solver. Here we can select which load case we want to see the mass and stiffness text file output. And also we can go for multi-threaded solver. This is optional. We can actually choose what we need. The other two are automatic. Also we have here analysis process options. So generally we keep it to auto. So we leave it if we really need to use advanced solver for track the result, otherwise it's not necessary. So we will leave it as it is, and then let's run the model and see what's coming up. So all models are run. P delta is done. Now it's going for running analysis cases with initiative P delta. Still we have some warning, guys. Let's track it and find where they are. So model analysis probably wouldn't be an option. We check all levels of slabs, so that wouldn't be any problem. Of course we haven't finalized ground floor meshing, but that doesn't give you any instability because they are connected to the columns and joints, so we didn't see any abnormal displacement here. So we need to check the displacement again. So let's go for envelope W. That will cover all vertical and lateral displacement, and we just need to check different areas. The roof is generally accumulative of all displacement, so let's have a look at some areas on the roof and compare with the displacement below. For example, here U3 is about 48 millimeter, up is 48.7, so it's just very minor change in the axial displacement. Here is 48 and 48, so those sounds reasonable. Here is 73, it's a bit more, so it's a bit suspicious. So when you come here, U3 is 70, okay, here is 130. Okay, so something is wrong in this area. So let's rotate the model and see what's happening here. So here we have 130 millimeter vertical displacement, which is not normal for such a structure. Here is 0. Okay, that means this pile is not connected to the pile cap. Likewise, here is 0. Okay, I think now it's clear what's happening here. Let's come down. Guys, I'm intentionally doing all of them with you because this is the life you have when you're running the model. There we go. So these joints are not connected to the shell, and we didn't actually auto mesh shell at this level. So if we run animation, start animation here, you can see these piles are not connected. These two are connected. Why these two are connected and the rest are not? Let's have a look at the model. So I'm coming to the last two piles which are here. They are aligned with the edge of the shell. So this pile and this pile are aligned with the edge of the shell, which is this and this. But you see the rest in this line, they are not connected with the shell. So we've done this actually subdividing for all edges, and this one I think either I missed it or I intentionally leave it there, but I forgot that I leave it there to list it. But that's perfectly fine. This become a bit more actual case, which is pretty good, and I'm quite happy of that. So what we need to do, we need to either go for this kind of subdividing, or we can use auto mesh as we know. So let's do auto mesh for this side. Okay, let's zoom back a little bit. Okay, I'm coming closer now. I'm selecting this side, and we can select all of them. It doesn't change anything, but probably we don't need it for the rest. Then we select all of them, and then we need to unlock the model, and now we're coming to assign area automatic mesh, and we're using this one based on point object because those are not point at the edge, so we shouldn't choose this option. We need to choose this option and then apply. Okay, let's see how we go. Running again. I'm really glad that it happened because that shows exactly the procedure that I try to explain you guys. I don't want to prepare a perfect video with no error because it doesn't add any value to you. This is typical challenge we have always, even for sometimes very simple models. Don't be proud of yourself if you can do something very quickly, because sometimes the mistakes are absolutely silly. Sorry of my language, but this is the reality. Sometimes we believe that we know everything. One of my colleagues, I remember, he modeled the switch room and everything was perfectly fine, and he's done it for maybe 5-6 switch rooms for the same project. But this one was very abnormal, the behavior. And we checked everything was absolutely great and correct. And when we checked the material property, we realized that he used concrete material property for steel. So when you see very big abnormal result, believe me, there must be a funny mistake there. So don't think that, okay, this part of analysis is okay, or this part of my modeling is fine. No, you need to check everything stage by stage. So it doesn't show me any error or warning because that was the condition I chose in analysis. If you remember, if I come here in set load case to run, I mention here if errors or warnings. So not always. How we can see that? We can come to the root folder of the file and go to the text file I told you. So this one, text document, and see if there is any error here. So let's scroll down and see if there is anything come up. So far everything is okay. And then coming to different load cases here, the periods are fine, and here is P delta, it's perfectly fine, doesn't show any abnormal or unstable conditions, and all done. So now the model is completed, we don't have any error, but we know there are some issues in our analysis. Again, I'm telling you guys, if SAP doesn't show any error, it doesn't mean that there is no error. That's why you are there. That's why you, as an engineer, using SAP just as a tool, and you need to judge if it's correct or not. We know that these slabs are not connected properly to the beams. We know the beam load are not correct, so the design of these beams wouldn't be safe. So we will go through this in our next module when we checking the result of analysis and moments and shear, and I will fix this level as well, and we have a complete model ready to go to show you the user interface and features for the design.